Okay, thank you very much. So this is a bit unusual talk for me because nothing of what I'm saying is my work, and I've actually not done any work on this so far. So the way this came about, I think 4 years ago, I met Victor for the first time, and on and off we've always been talking about this question, what is money? I was actually surprised when Victor told me that there's no economic theory of money. And after all these years of working on open games and maybe other concepts combining other concepts from computer science with economic ideas, we think it's maybe now a good time to come back to this question. And one concrete thing one could try to do is, I mean, you can always start at the concept. You could start at the level of economics, but you can also just kind of start at the bottom and see what is kind of the what kind of mathematical models are there and how we might want to modify them. So Victor gave me this book, Algebraic Models for Accounting Systems. And I've not done more than reading that book. So all I can do is to give you a quick overview of what is in there. And then maybe Victor can come in and explain why you think this is interesting in terms of the big picture. I also have two ideas where we can kind of maybe use more of computer science ideas on this. So, I mean, one reason why I wanted to put the book here is to make really clear that this is nothing of what I'm going to say is from me. The other reason is that I wrote some notes, but I thought it's actually easier to just put up the table of contents and instead of looking at my own notes. So chapter 1 is just some overview. So mathematically, it starts in chapter 2. And so the first question is, what are the values which we want to use in an accounting system? And I think some of the authors are mathematicians, and maybe some of them are economists. I don't even know. But yeah, so they start with some traditional mathematics. So they think about like what are the properties values need so that we can use them for accounting. And basically what they're saying is we should use a commutative ring, which is called R throughout the book, and it should be totally ordered as well. So we want to talk about debts and about assets. So we need kind of we need that this ring has a notion of positive and negative numbers, if you want. And then the next question is like what are accounts? So the idea is to again, classical mathematics, you work in a vector space or maybe in a module, right? Because there's no requirement that this ring is a field. And then the dimension, so the dimension of this vector space or module, that's the number of accounts. Yeah, so this is, of course, a very intuitive idea because if you have n accounts and you have a vector where the values are taken from that ring, you just think of this as a state of an accounting system. So the easiest and the basic kind of the smallest framework in accounting system is the free module over R of dimension n, which, okay, so one constraint. So this is where it gets a bit more interesting. So these vectors should be balanced. So they write this module like this. So the set of balanced vectors of dimension n over the ring R. And what does it mean to be balanced? It just means that the sum over all of these a sub i's is 0. So this is how this crucial idea of double, what is this called? Yeah, exactly. Double entry bookkeeping is built into the system.
So we think of this vector space, it carries a canonical basis, so we can see
Yeah.
the account.
Yeah. Okay, so this is basically chapter 2. So let's go to chapter 3. So you want, obviously you want to have transactions. And transactions are just, so this, they prove some things, right? So there's a little bit of mathematics in this book, but I don't think it's too important for the summary. So for example, one thing I prove is that this is, but I mean, yeah, it's kind of obvious as well, right? So I mean, this is also, the balance vectors are also a free module, but of one dimension less, because this constraint kills exactly one dimension. And you can see these balance vectors as kind of a hyperplane or something, maybe. Yeah, so there are some results in, throughout the book, and I don't want to say too much about it. But yes, don't assume that the book contains only what I'm saying. That's the point I want to make. Just want to go to the, so what are transactions? So these balance vectors, they can be accounts, but they can obviously, they can be also transactions, because you just, I mean, so I think, what is the notation they use? I think they use a B for balance vector for the state of an accounting system, and then a V for a transaction, and then the transaction is just that you add these two vectors. Okay. Oops. So I have something here. Okay, so this is transactions. And then there's some stuff about different ways of representing transactions, or maybe representing types of transactions in as a directed graph, and these kind of things. So then in chapter 4, we have, like now, what is an accounting system? So an accounting system is now a set of accounts, and the cardinality of this set is just, in this example, it's just n, right? Or n plus 1. Actually, they always start at 1 here. Let me also start at 1. So a set of accounts, or we could also just say a natural number. And then there are two subsets of these balance vectors. And we think of these as the allowed states, and these as the allowed transactions. And maybe sometimes you have an initial state as well if you want. So they don't exactly consider this as a category, or at least only implicitly, but they have a notion of an homomorphism. So homomorphism is a map between accounts, and it must be compatible with allowable transactions and allowed transactions and allowed states.
Isn't the A totally redundant?
I mean, it's just the number n, but you can.
Yes.
The number of accounts can change here. Yeah. So, for example, you want, that's One example they have is that they want to have a co-product, right? So this is, now we're getting slightly more into this question of how to compose accounting systems. So they discuss composition as basically disjoint union. And then they discuss also quotients. So quotients are more interesting because now you can merge accounts. And how this works is if you so how do I suppose. So AI, so this is the value of the account number I. Let me write this here, maybe AI prime. That should be the sum of the values of all the accounts such that this map here is mapping A to AI. So maybe I shouldn't call this, I don't really need the subscript here, right? I don't need it at all, A prime. So this is a notion of composition of accounts where you can merge accounts. So you have disjoint union, and then you can, if you want to merge accounts, you need to add up their values. I think that's quite a natural thing to do.
Can you say what the allowed transaction thing does? Because it isn't contingent on the state, for instance. So it isn't a function of our bank balance. What does it prevent and allow?
I think it's just as, yeah, so I didn't, so T is a subset of balance vectors and B as well. So this is, I mean, you can imagine that you're not allowed to have, I don't know, more than 1 million on an account, for example. So that, then you could express this by saying that not all balance vectors are allowed as state of your accounting system, and in the same way you can exclude certain transactions.
You can prevent massive transactions, but you can't prevent you going into debt, for instance, using T.
No, I don't think so. Yeah. No, but I mean, let me think about it. I mean, this is, I mean, okay, so they have a notion where they consider then the transitive closure of T as well. And, but in the basic case, I mean, this is just any subset. It doesn't need to have any, there are no constraints. So you can, really forbid and allow any transaction you want. Yeah. So one question one could ask here, so is whether this this notion of composition is maybe a bit too simple. So we've been talking about open games. So maybe, so is there a notion of open accounting systems? I mean, now it's true that I don't know anything about accounting, right? So I don't know what problems a notion of open accounting systems could solve. But like if I may think of a company or a business which could have like lots of accounts, right? And then probably you don't want to expose all accounts to the outside. Yeah, so it could make sense to have a picture where you have kind of wires coming in and out, and then maybe composing only via an interface. So we also have seen different ways of doing this, I think, yesterday with using co-spans in the presentation by Brandon, and then yet another way of making graphs compositional by Pavel. So there's potential of doing something here as long as we are kind of guided by what what kind of accounting systems there exist in the real world. So so this is also what we just briefly talked about, right? It wouldn't make too much sense to just kind of start developing some mathematics here in a random direction. But I think that could be an interesting question to think about.
I mean, the company SAP is an accounting system, more or less. They implemented. So in that sense, they would definitely need the open accounting systems just to be compositional and plug-in.
Yeah, but how do they compose accounting systems? I don't know, right? So one would need to look at some examples and then understand how to model them mathematically.
I guess they are not composing it in that sense, but just to code it and then charge you the money for it. That's the business model. Yeah, completely. That's why it doesn't work. So that's why their problem is the following. So they are sitting on the data, which is completely crazy. Any beer in the world is ending up in a SAP system. But there are so many around there in versions that they cannot, in a unified way, kind of query into these essentially hugest possibly database of economic transactions, because exactly they are not in that sense interfaced together. However.
So one example that we just discussed with Victor over the break is like if you have a central bank, and this goes to the question like what is money, right? So if you want to understand what money is, you have to think about how does the central bank creates money and how do the banks create money, so like the high street banks. And there's obviously a lot of accounting going on inside every bank, and then every night, as Victor told me, there's a lot of accounting going on between the banks, and then there's also accounting going on between banks and central banks. So it would be, I mean, if something like this is interesting, then that should be one of the examples, right? So we can compose a big accounting system from smaller accounting systems. Yeah, and money is definitely something that the meaning of money is kind of has to do with the way the information flows in such a system. Right? So if you understand accounting systems better, and we can model something like that, then we can also maybe understand what money is about. And yeah, certainly. I mean, money has to do with how information flows in the economy, so why not trying to say something about it from the point of a computer scientist? So I think that it's definitely an interesting idea. Okay, so that was the first question I had, and then what else do they do? So if you look at this, that looks a bit like an automaton, right? So you can think of this as a transition function of an automaton. And basically, they study, so which chapter is this? Okay, so 6 and 7 is kind of some introductory material about automata. And in chapter 8, they discuss a classical verification problem from theoretical computer science, namely reachability. So this balance verification problem is really just a reachability problem. So you have this initial state, maybe we call it B0. And then you have a state, kind of a final state, supposedly final state, and then I don't know how they call it, the auditors or so, like which will maybe want to know whether it's actually possible, whether there's a possible series of transactions which connect the initial state to the final state. So now, if you know a little bit about theoretical computer science, then and verification, then reachability is only one of the very basic verification problems we consider. So there's an enormous amount of literature on model checking, for example, which is a much more sophisticated, which allows you to check much more sophisticated properties than just reachability. So, so then again, I mean, that would be a question to somebody who knows something about accounting. So the question here would be, are more sophisticated properties than reachability of practical interest in accounting, more sophisticated properties than reachability. So if we find an application that would be of interest for somebody in accounting or economics or like these big companies who are doing auditing, right? Deloitte and what are they called? PricewaterhouseCoopers and so on. They're in deep trouble right now, right? Because they let so many big companies go bankrupt, Carillion and so on. So if we can solve some of their problems, I think there would be a lot of money in there. So, but I don't know, right? So but certainly that's just from looking at the book, there's a potential here to export computer science technology. So yeah, so that was my second point I wanted to.
But the system, by the way, is mainly infinite, right? The accounting system.
Yeah, but you can abstract away from.
And if it's infinite, then reachability is also more or less what they're doing.
Yeah, so they use a simplex kind of algorithm to solve the it's infinite, but and they don't use kind of a brute force enumeration. They use a variation of the simplex method to do this. But you can imagine also that, I mean, you have maybe infinitely many transitions because you have infinitely many values you can have in a but if it's unbounded.
You've got a finite supply of money in the world, so it's finite, it's massive.
Yeah, but it's probably big enough to.
Yeah, but it is finite.
Yeah.
It's not infinite.
It's not finite in the sense that you can write
It's not manageable. Yeah, it's not manageable. It's finite.
But there are also, I mean, in this model checking literature, there's a lot known about abstraction, right? So I mean, and probably the interesting transitions that you want to allow or forbid, you can allow and forbid them. You can describe them in some finite way. Yeah, there will be rules which tell you this is an allowed transition and this is a forbidden transition, and there will be a finite number of rules. So even if the transition system is infinite, I mean, there's still, I think we have the technology to do something there.
Do reachability for sure, but I'm not sure about much more than sophisticated reachability. I mean, there are a lot of ways of doing reachability for infinite systems. But anyway.
Yeah, I mean, I don't even know what exactly the problems are that one could study here. Yeah, so I'm just saying there's a potential to do something. Yeah, and then what else is there in the book? So they add a bit of extra kind of machinery, that's what they call the extended model. So slightly more fine-tuned mechanisms of controlling which transitions are allowed and which are forbidden. And then in the last chapter, there's a bigger example. Okay, so yeah, that's all I prepared. Thank you.
tell something about this 10-tuple model? I mean, what kind of information is coming? I mean, I don't want to have all the 10 tuple stuff, but I just want to know what kind of stuff.
I mean, I read this book yesterday night, so you can't expect too much.
So it must be fresh in memory.
So basically, I think from this chapter, I just read the first page or something, and then I forgot it again.
How did you find this book in the first place?
Yeah, Victor is.
I don't know, the magic of composing suitable words into Google.
So to be completely honest, yeah. So this morning when I read this chapter, I read in this chapter it is shown how to attach two further security mechanisms to the basic model, and then I stopped reading. So I can't really tell you much more than that. But I don't think that, I mean, our interest would not go, I mean, at least that was my intuition, that our interest would not go into make their model even more kind of complicated, but rather try to add things that, like, for example, I mean, to think about this compositionality would probably be an interesting thing to do.
My question more seriously from what it would have been, how much is this a toy model and the 10-tuple model is a real thing? Because this looks very nice, right?
Yeah, so there's, probably it's still a toy what they're doing. That would be my guess. But then I don't know enough about accounting to be able to judge it. But they have some nice ideas. Yeah? So for example, that you have a complicated accounting system, and then you use these homomorphisms to do, I mean, such a homomorphism could be a report, right, which you then submit to an auditor. Yeah, so there are some nice ideas.
For example, this checking, reachability and everything, that's actually the business of the whole regulation bodies of finance, market regulations. They should check this kind of systems by these methods.
Yeah, you can also bring it back to what we discussed before about smart contracts, right? So then you could maybe set up a company where an accounting system is already implemented, and then these properties are guaranteed by design, for example.
So these state transitions are obviously smart contracts. You can have anything you want running on that.
And about the realness, reality of this, I don't know, but I also scanned the book Victor, so but it is like proper double entry booking thing. So like that's totally covered by the thing. It's not a fake model in this way. But the problem is financial instruments like way above this thing. That's not captured by this. So
Yeah.
like how do you put some like an option for something in the future in the book?
Yeah. So this is all the state transitions are then these smart contracts. You have to say what you book when you execute a contract. So the booking is, but you have the automaton, so you can do what you want.
Yeah, so this is again, I think what you said, it goes back to this question of compositionality again. Right, so what they have is very rudimentary, disjoint union and quotient. So yeah, I think this is certainly something could be worth looking at. Yeah.
Oh, I was just curious, the table of contents mentioned a real-life example. I was curious how real.
Yeah, again, I wouldn't be able to judge this because I know nothing about accounting. Yeah, so this is also why I didn't pay much attention to this chapter, because to me anybody can say anything about accounting, really. Yeah, so
I think
maybe it would be interesting, yeah, to get somebody. Yeah.
I think the interesting part here is that so far not really formalized double accounting is connected to very well-known principles, invariances. In fact, I mean, actually, the question is, isn't it the symmetry of booking two things at the same time which creates this invariance? So we are back into symmetries, invariances. So meaning that once this accounting stuff is put into such mathematical form, all kinds of math can be solved in it. I think that's the basic thinking.
But can you look at these monetary things without other stuff? You know, this is kind of just the big book of money, and then you don't have any orange juice on which you can take your future contracts, and you don't have any actors. Or any, I mean, how much can go on with an accounting system? Is that already economically interesting, just chaining accounting systems together?
So now the step. So why I'm interested in that. So as from a money theory perspective, if you now make the accounting system to be the national accounting system, then the smart contracts which you need to model and then use all these complicated or powerful mathematics for these complicated things, the smart contracts would involve the whole banking system. So commercial banks create credit, central banks create money, investment banks trade money, the bank of central banks create central banks, so that would be an automaton, a booking on an accounting system, and then you can imagine you run into severe mathematical difficulties here, then you need this starting point. That's the point.
I just wanted to mention a reference, which is, I heard you were talking about accounting, and I thought you would be talking about a different thing, which is a paper by some Canadian Walters from the called Contract Idea, where I think accounting systems are one cells, cells,
I've seen this.
yeah. I don't quite understand that, but I just wanted to throw it out there as another categorical accounting system.
Okay, further questions?
And maybe just to add something to what Victor said, I mean, here at the moment, this is a constraint, and then we have these constraints here, which are not kind of further analyzed. But yeah, so it could be, I'm sure there are many more interesting ways of adding constraints to this picture. And again, I mean, computer science, we have quite a lot of literature on such systems, so